Richard Feynman once said, "No one understands quantum mechanics." In reality, physicists consider quantum mechanics to be a highly counterintuitive field of study. The general public often perceives a disconnection between quantum mechanics and the everyday world, leading to common misconception and a lack of familiarity with quantum concepts. However, quantum mechanics is intricately connected to our daily lives and is a fascinating discipline. So, what is a quantum? We tend to think of energy as continuous because we are too large compared to atoms. However, energy can only have discrete values, much like steps on a staircase. When energy or momentum is continuously divided until it reaches the step of the smallest unit, we call this unit a quantum. Now, let's explore how quantum mechanics came into existence and how it guides our interpretation of the world. To delve deeper into quantum mechanics, it would be helpful to first contemplate light. What is light? Some may say it's what illuminates darkness, while others may describe it as an essential nutrient needed for photosynthesis in plants. However, let's discuss it more fundamentally. Is light a wave or a particle? In the 17th century, Isaac Newton, through his book Optics, proposed that light consists of particles. Newton, who revolutionized physics with his equation F equals ma, was highly regarded by physicists of his time, and optics was revered like a Bible. Therefore, it was believed that light was composed of particles. However, in the early 19th century, Thomas Young's double-slit experiment revealed that light exhibits interference. Since interference is an intrinsic characteristic of waves, physicists started to regard light as a wave. Furthermore, James Clerk Maxwell successfully predicted the speed of light through his equations, solidifying the understanding of light as a wave.
That was the case before this genius emerged. Einstein, through the photoelectric effect experiment, revealed the light exhibits particle-like properties. In the end, the physics community defines light as a paradoxical substance possessing both particle and wave characteristics. Such shocking results bring significant inspiration to physicists. The realization that light, which was thought to be a wave, exhibits particle-like behavior, then could it be possible that substances believed to be particles are actually waves? Du Bois explained through his matter wave theory that electrons can also possess wave-like properties. In other words, electrons exhibit the duality of waves and particles. In this context, quantum mechanics was born to describe electrons which were unpredictable classically at that time. To explain unpredictable electrons, Heisenberg creates a wave mechanics called matrix mechanics, and Schrödinger creates a wave mechanics called the Schrödinger equation. The two mechanics turn out to be mathematically equivalent. However, their nature was different. Heisenberg argued for discrete space and Schrödinger for continuous space. Since Schrödinger's wave equation was more familiar mathematics to physicists at the time, many physicists accepted Schrödinger's equation. Meanwhile, the Copenhagen school, including Heisenberg, Bohr, interpret the wave equation as probability to maintain their discrete space, which is called quantized space. That is, we can tell the location of electrons only in probability. Also, this means that Every time we measure the position of an electron, the position of the electron can change. In other words, they can teleport. Of course, there are many physicists who criticized their interpretation. One prominent example is Albert Einstein. Einstein's famous quote, "God do not play dice," is a story that came out criticizing quantum mechanics.
Schrödinger also criticized this idea and proposed his thought experiment, known as Schrödinger's cat paradox. According to the Copenhagen interpretation, until observed, all states exist in a probabilistic superposition. To criticize this, Schrödinger proposed a paradoxical scenario, where a cat, when placed in a poisoned box, would exist in a superposition of both dead and alive states. However, this example explains the Copenhagen interpretation very well. The Schrödinger's cat paradox becomes a representative example of explaining the ambiguity of quantum mechanics. Also, the Copenhagen interpretation was accepted by the physics community because it matched the experimental result so well. So far, we have looked at the background of the birth of quantum mechanics and the process by which quantum mechanics was equipped with a logical system. Quantum mechanics seems distant from us and is filled with formulas and complex scientific interpretations. However, it has dramatically changed humans' life. The video shows the structure of MOSFET, a key component of electronic devices. Source, gate, and drain are the parts connected to the external voltage source. When MOSFET works, a minute current flows below the SiO2 layer. If you look closely, SiO2, an insulator, exists under the gate metal. According to classical mechanics, electrons cannot move because they are blocked by a barrier. However, MOSFET work well because engineers designed them with quantum leap in mind. In other words, most of the electronic devices you use every day would not have been as advanced as they were without quantum mechanics. Quantum mechanics is deeply infiltrated into all of our actions, such as answering the phone, watching YouTube videos, and surfing the web.
In summary, light is quantized into the smallest unit, called a photon. The fact that the waves like light can be interpreted as an aggregate of photons means that light has duality. From our point of view, living in the macroscopic world, atoms, electrons, and energy behave against our intuition. There have been numerous controversies, from Newton's claim that the light is a particle to the modern duality. Thomas Young argued that the light is a wave through the double-slit experiment, and Maxwell solidifies the position of wave theory through Maxwell equations. Einstein argued that the light is a particle through the photoelectric effect. Du Broglie argued for material wave theory, and Heisenberg and Schrödinger solved the wave function in their own way. Contrary to Einstein's claim that the quantum theory is incomplete, quantum mechanics is accepted as an established theory in modern society. The debates of the ancestors moved to Ophüven. Quantum mechanics is hidden in all electronic devices we use, such as QD, OLEDs, transistors, and smartphones. Starting from the simple proposition that light is made up of particles, the quantum changed the way we perceive the world. This is the charm of quantum mechanics. Quantum mechanics is a mystery that started from the most common, no one understands, but exists everywhere.